Just make sure okay, you have a calculator with you. Summer 21. The first one, state the meaning of the term. You can send them on WhatsApp. Okay? Make sure and try and send them on in the WhatsApp group. क्योंकि वो individually ना आंसर करना थोड़ा सा difficult होता है. It's easy to follow a group. So this one, carbons are volatile. Volatile means it's got a low boiling point and it evaporates quickly. And it easily evaporates. Here the next one, draw the Dorian cross diagram of a CS2 molecule. So carbon would want to share. Remember, carbon is group 4. Group 4 makes 4 bonds. Sulfur is group 2, so group 6, it makes just 2 bonds. So this is what it's going to look like. There's going to be a sulfur, there's going to be a sulfur. Beach where there's going to be a double bond. So carbon would share 4 electrons. Remember, group 4 shares 4 electrons. 5, they share only 3 electrons. 6 shares 2 electrons. And 7 shares 1. And sulfur will have 4 electrons remaining out of its 6. Out of its 6 valence electrons. Suggest the bond angle in a CS2 molecule. So what is the bond angle over here? Kya hoga when you just have 2 bonds? What's the angle? Sidra, Oswa? You just have 2 pairs of bonds. So what is the angle? That is 180 degrees. Yes, it's linear. Just a quick revision. 2 bonds, that's 180 degrees. 3 pairs of bonds, that would be trigonal planar. 4 bonds, that's going to be tetrahedral. And then there's going to be a lot of variations out of these shapes that if you have a lone pair, then it's going to be trigonal pyramidal. If you have 2 lone pairs, that's going to be bent. Either be if you have 1 lone pair and 2 bonds, that's bent or nonlinear. 5 bonds is trigonal pyramidal. If something has 5 bonds, that would be trigonal pyramidal. And 6 bonds would be octahedral. Anyways, next one. CS2 is a liquid under room conditions while CO2 is a gas. Explain what causes the difference in the physical properties of CS2. Now, both of them are kind of almost the same. So you have carbon dioxide and you have, because oxygen and sulfur are almost in the same group. So their bonding is almost the same. Everything is exactly the same. Is this polar or non-polar? Okay, what type of intermolecular forces do they have? Do they have dipoles or not? Okay, jab linear hota hai, what happens? The dipoles, oxygen is more electronegative, so oxygen will try to pull electron towards itself. The other oxygen is also electronegative, so what happens is that the dipoles, they cancel out. Either be yoga, sulfur is more polar, is more electronegative. So they're going to try and pull the electrons. I'll just add a thing over here, which is they've included the Pauling scale now in the latest syllabus data booklet. The Pauling scale gives you an idea about the electronegativity of the elements, which we already know. Okay, which one is electronegative, which one is not. But now they've also given you values for that. वो देख लें table कहाँ पे है. So this one. So you're given electronegativity values. Remember, electronegativity in the pure table increases towards the right, and it increases upwards. So Pauling scale is simply, it gives you a value that fluorine over here is very electronegative. So so that means, I mean, you know that these elements are electronegative. The ones that have a low value are not very electronegative. They don't like to gain electrons. But anyways, that's your Pauling scale. And अब इसमें ये कि remember, if there's a huge difference in electronegativity values, if the difference is greater than 1.7, then the compound is going to be ionic. This if I take Na and if I take Cl, so Na and Cl has an electronegativity of 3, Na has an electronegativity of 0.9. So the electrons are going to be completely gained. So they're going to be completely gained by Cl. Cl would be -1 and Na would be +1. So it's going to be ionic. Okay, so if there's a huge difference in electronegativity, the molecule or the compound is going to be ionic. If there's a very small difference in electronegativity, then they would be sharing electrons. No one would be able to gain electrons. So यहाँ पे CO2 की बात हो रही थी. So you had C with O. O had an electronegativity of 3.5. This other O had an electronegativity of 3.5, while carbon had an electronegativity of 2.5. So oxygen was more electronegative. But the force of attraction is going to get cancelled out. It's not going to have a dipole. Why? Because one oxygen is pulling electrons towards the right, the other one is pulling the electrons towards the right, towards the left. तो वो एक दूसरे को cancel out कर रहे हैं. ठीक है, so the only force of attraction that they have is it's going to be van der Waals. They won't have a dipole. No hydrogen bonding as well. So only van der Waals forces. So why is this a liquid? It has a higher boiling point. Why does it have a higher boiling point? Because it's got stronger van der Waals forces. Bigger molecules have more electrons. They have more electrons, because of which they have more temporary dipole, induced dipole. Temporary dipole, instantaneous dipole, or induced dipoles. So you're going to write about this. TK, is this clear? Sign clear? Also, is this clear? Sidra, is this clear? I said next is define the term enthalpy of combustion. So it's the energy that is released when what happens? When 1 mole of a substance, so 1 mole of a substance burns in excess oxygen, measured under standard. Now, since they hadn't used the word standard, so I'm not going to talk about standard conditions. I'll just quickly refer to uska if they've given marks for that. Okay, so they're not giving any marks for standard conditions because specifically in the question they had not used anywhere the term standard. So that means nothing was happening under standard conditions. Standard, there should be a not on top, which wasn't there. So this wasn't standard condition. So the definition should not include the last statement that it should be measured under standard conditions. Use the data to calculate the enthalpy of combustion of CS2. So this is what you have to calculate. So you've got CS2, which is a liquid, and it's going to burn. How did I know it's a liquid? It's given over here. And it will burn and it will produce carbon dioxide, which is going to be a gas, and SO2, which is going to be a gas as well. And it's going to be 2 SO2 and 4 plus, that's 6 oxygen, so that's 3 O2. Now so this is the enthalpy change that you're looking for. So the formula is, you're given the enthalpy of formation of CS2. So that's given delta HF. You're given the enthalpy of formation of O2, which is not given in the question, but that is 0. The enthalpy change of formation of elements is always 0. You're given the enthalpy of formation of carbon dioxide, and you're also given the enthalpy change of formation of of SO2. So that is all known. And this value is 0. So that's given, all of this is given in the table. So the enthalpy of this reaction is going to be product minus reactant. So it's going to be the enthalpy of formation of the products minus the enthalpies of formation of the reactants. So you do the math, the products are over here. So what are your products? CO2, that's minus 394. You could jaldi se solve kar le. Minus 394. SO2 is minus 297. That's 2 times. So that's my product minus my reactant, which is CS2, which is 89.7. And the other one is 0. Yukib Tadu did this. It's 1 minus 1077. So I'll just quickly check this. It's coming out to minus 1080. So again, be careful. The values were accurate up till 3 significant figures. So your answer should have been rounded to 3 significant figures. It should have been minus 1080. Okay, make sure, be careful about this. Your answer cannot have 4 significant figures. It can't be more accurate than the data that's given. I just state the meaning of the term weak as well as acid. Acid is proton donor. Weak means it partially ionizes. So a weak acid is a proton donor which partially ionizes. Give the formula of the conjugate base of H2S. So you're seeing H2S is a slightly soluble, it's slightly soluble in water. It acts as a weak acid in aqueous solution. So what happens is that H2S over here, if it is a weak acid, it acts as a weak acid that's provided over here. That means it's going to lose an H+1 ion. So if it loses an H+1 ion, it would form the HS-1 ion. So it's behaving as a weak acid. So any weak acid, when it ionizes, it turns into a conjugate base. And what is a conjugate base? A conjugate base is the opposite. What a conjugate base is, that in the reverse direction, it's going to gain the H+1 back again. So that's why it's behaving as a base. And explain with reference to oxidation number why this reaction is a redox reaction. So it's, just S is -2. Over here is 0. Over here is -2. And now S is 0. So you just give the reference that H2S goes from -2. Sulfur goes from -2 to 0. So that means it's getting oxidized. It loses electrons. And you can talk about the other one, which is O2 turning into H2O, where O is -2. Over here, O is 0. So that means it's getting reduced. It gains electrons. Moles pe. It's heated strongly, and a sample containing this thing is placed in 0.1 dmq of pure oxygen in excess. So this is 0.1 dmq, but remember this is excess oxygen. Okay, so that's excess. As a calculator again, this is 0.198 grams. Can you figure out the moles of this? 0.198 grams divided by the MR. Silver, that's astatine. So that's I'm not sure what astatine is. So the astatine over here is 74.9. That's given as 74.9. So 74.9 times 2 Sulfur is 32.1 times 3. So mass divided by the MR. So how many moles do we get? क्या आ रहा है इसका? 0.198 grams of this thing. अच्छा 8.05 into 10 to the minus 4. अच्छा इसके moles. The moles that you're getting is 8.05 times 10 to the power minus 4 moles. Okay, I just wrote it over here. So anyways, the reactants are heated until no further change is observed. The products are then allowed to cool to room temperature. Calculate the volume of gas present at the end of the... So you know that this is 8.05 into 10 to the minus 4, right? Moles. Use ratios to figure out the moles of all the other substances. What would be the moles of O2? It would be 8.05 times 10 to the minus 4 divided by 2 into 9. What do you get for that? Oswa Sidra kya assign? How many moles of O2 do you get? How many moles of this thing do you get? How many moles of this thing do you get? 8.05 times 10 to the minus 4 divided by 2 into 9. What do you get? पहले वाला कर लेते हैं. अच्छा, getting 3.62 times 10 to the minus 3. ठीक है, 3.62 times 10 to the minus 3. अच्छा, what about the next one? 8.05 divided by 2 into 1. So basically it's just divided by 2. What do you get? .025 times 10 power minus 3. ठीक है. And I said, remember, make sure, also I think you made this mistake. Make sure while you're working, don't round things off. Which of anyway, final answer, that should be to the appropriate significant figures. But before that, don't do any rounding. Make sure try to use as accurate a value as possible. So this one, the last one, SO2, that's 8.05 divided by 2 into 6. What do you get? 2.415 minus 3. So we've gotten all these values. Now, he's saying calculate the volume in dm cube of gas present. So first thing, this is the gas that we are getting. That's my product. So first thing, I'm going to figure out the volume of SO2. And he's already given me that the molar gas volume is 24 dm cube under these conditions. So we're going to just multiply it by 24. So can you tell me the volume of, like if you multiply it by 24 dm cube, how many dm cube do you get? What do you get? So this is 0.05796 dm cube. Or be end without rounding karte. So this one. Now he's saying calculate the volume of gas present. He's not asking for the volume of only this thing. He's talking about generally what is the volume of gas. So there's going to be, remember he added excess O2. He added 0.1 dm cube, and out of that 3.62 into 10 to the minus 3 moles got used up. So we're going to try and calculate the volume of O2 that got used up, or that took part in the reaction. That's 3.62. So that's going to be 3.62 times 10 power minus 3 into 24 dm cube. So what do we get for this? So the answer is 0.08688. So this is the amount that got used up or that reacted out of how much? 0.1 dm cube. You can remember right at the start, he said that 0.1 dm cube was added. So 3.62 got used up. So if this got used up, how much is left? So what is the amount of O2 that's left? Subtract this thing from 0.1. What do you get? Sidra Oswa, what do you get? 0.01312. So the oxygen that is left is 0.03, पता नहीं क्या था, 0.01312. So 0.01312 dm cube. So these were the only two gases. So there was some amount of SO2 that was produced, and there was some amount of oxygen that was still left, which is 0.013. Add them together. So add these two things together. So what is the total volume that you're getting? It's so the final answer is 0.07108, and I'm going to round it off to 0.0711 dm cube. Now, this question had a lot of addition and had a lot of subtraction. So there's a very bright chance of making silly mistakes with this one. It's everything I think is 3 significant figures. So my answer, my final answer is actually 3 significant figures, and I'm gonna check this. So he's actually, if the final answer rounds to, so only about the 4 rounds 2.0. So he's saying if it's rounding off to this thing. I mean, this one is given. Why are we not getting 711? Try and make sure that, but anyways, you'll still get the mark. Then only award the 4th mark if the final answer rounds to this thing. And the minimum he's accepting is 2 significant figures. So this is fine. We're not losing any marks anywhere. But remember, accuracy and significant figures. State the environmental, that's acid rain. And what does it do? It makes the soil acidic. SO2 can be removed by reacting with any construct an equation. So what happens is, think of SO2, whenever you have SO2, think of it as sulfurous acid. So when you're making an equation with NaOH, the salt that is going to be formed is going to be sodium sulfite plus water. So always think of it as a reaction of sulfurous acid with NaOH. And that was, and the first question was pretty big. It's 21 marks. Let's try the next one. It's identify the product produces. Reaction number 1, calcium with acid produces So metal plus acid produces salt plus H2 gas. Then you have construct an equation for the thermal decomposition of calcium nitrate. This part over here, so you can do that. Nitrates, they always decompose to form a metal oxide plus NO2 plus O2. No need to write state since it's a 1-mark question. State the trend. So the carbonates and nitrates, they become more stable down the group. In reaction 3, excess CO2 is bubbled through water containing calcium. Solution of this is formed. Consider an equation. So everything is given. It's CO2 and it's bubbled through water. So I think there is water involved containing calcium carbonate, and a solution of CaHCO3 twice is formed. This is what the question reads. I've added water because they were using the term water. It's bubbled through water. And there has to be water because there's H over here. It has to come from somewhere. So the equation looks balanced. Describe how this is used. It's used as lime and it neutralizes acidic soil. So this is pretty standard, basic O-level stuff. This one, describe how sp hybridization, hybridized orbitals are formed. So sp hybridization happens due to the mixing. So it's the mixing of one s and one p orbital. Okay, let me check what and I'll explain what hybridization is. What is sp hybridization? Sp hybridization is when carbon forms 2 pi bonds. So what happens is, and this is exactly what they're looking for as well. What happens is carbon has 4 electrons. But in sp hybridization, carbon is only bonded to 2 atoms. So out of the 4 electrons, 1 electron gets pulled in this direction, 1 electron gets pulled in this direction. So there's some atom over here that's pulling that electron. There's some atom over here that's pulling the electron. So 2 of carbon's 4 electrons, 1 of them gets pulled in this direction, 1 gets pulled in this direction. The other 2 remain kind of unchanged. So there's 1 orbital that remains unchanged. And there's another orbital which also remains unchanged. So 2 of the p orbitals, they remain unchanged. So remember, carbon had 4 electrons. So out of those 4 electrons, 2 of the electrons have changed their shape. They've become sp hybrid orbitals, while the other 2 have not changed their shape. And then there's going to be another carbon which is going to be exactly the same. So he's asking you to draw a sigma bond between the 2 carbon atoms. So what's going to happen is one of carbon's electron being pulled in this direction, 1 carbon electron being pulled in some other direction. So these 2 would start to overlap in the middle, and that's all you have to show over here. I don't think he's just sketching. He just wanted to show the. So is this part clear? You clear? So I'll just have a look at. I mean, that's it. The middle part. That's it. I mean, they weren't. I think they actually wanted to show you. They wanted to see that as well. So sketch 2 sp can form a sigma bond. So 1 mark is for this, and the other one is for this. So So you have to actually show how the, I mean, this part is fine. There's nothing wrong with this. Okay, so the electrons are now in the middle. And you have to show that the electrons are being pulled in either direction. So maybe you can show this, that before the bond was formed, they were pulling each other's electrons and they started overlapping in the middle. Let's try and continue with the same question. I'll just at the end, because this one is important, I'll just remember hybridization. I'll just quickly go through that. sp3 hybridization is when carbon bonds with 4 atoms. So all 4 electrons, they get pulled in 4 different directions. That's sp3 hybridization. And usually 4 sigma bonds are formed. sp2 hybridization is that carbon is only bonded to 4 atoms. So 3 of its electrons get pulled in 3 different directions by 3 different atoms. The 4th electron is forming is going to form a pi bond. And sp hybridization is that carbon is only bonded to 2 atoms usually. So what happens is 2 of the electrons get pulled in 2 different directions, and the remaining orbitals, they remain unchanged and they end up forming 2 pi bonds. So over here you have a triple bond. Over here you have 1 pi bond, which makes it a double bond. And over here you don't have any double bonds, only single bonds. So let's continue with the same paper next time, ठीक है? और इसमें कुछ चीज क्लियर नहीं, मैं पूछ लेना, ठीक है? Okay, everyone.